Hello everyone. In this video we are going to solve a system of two equations. So the equations are root x plus y is equal to 7 and x plus root y is equal to 11. So solving these equations is not as simple as it looks like because we have radicals, right? So we have to try to get rid of radicals here. I will show you two methods in which we can solve these equations effectively. Okay, the first method is more creative and the second method is the method which you all know. Okay, so let's wait for that method. So I'm going to name this equation as equation number 1 and this one as equation number 2. So I will take the first equation, root x plus y, and I will bring this 7 to the left side, okay, so that we have minus 7 equal to 0. Now root x plus y, I will break this minus 7 as minus 3 and minus 4 equal to 0. What I'm going to do, I'm going to write this minus 3 with this root x, okay, root x minus 3, and I'll write minus 4 with y is equal to 0. Now I'm going to group this root x minus 3 together, okay, and this is another group. I want to factorize the second one somehow. It's a linear polynomial, right? Can it be factorized further? Okay, generally we may not be able to do, but we have to apply some creative tricks here. I'm going to use this identity, that is a square minus b square. This is equal to what? A plus b times a minus b, right? Okay, so we have y minus 4. So we have y minus 4. 4 is nothing but 2 square. Okay, that's good enough. But can we write y as a square? Y may not be a perfect square, but we can write it as square root of y the whole square, right? Let me use some different colors for better clarity. Yes, so we can write this as root y the whole square, right? So using this we can expand, okay, we can expand this one as square root of y plus 2 and square root of y minus 2. Okay, this is how we can factorize this. So let's substitute it here. So we have got root x minus 3 plus y minus 4 can be written as root y plus 2 times root y minus 2 equal to 0. Let me keep this as equation number 3. Let me keep this as it is, and I'm going to work with the second equation now. That is x plus root y equal to 11. Let me write this equation here. So we have, okay, sorry, it should be x plus root y equal to 11. I'm going to bring this 11 to the left side so that we have x plus root y minus 11 equal to 0. Now I will write x plus root y as it is. I'm going to break this minus 11 as minus 9 minus 2 equal to 0. And I'm going to write this minus 9 along with this x. So we have x minus 9 as one group plus root y minus 2 as the second group. Okay, now using the same concept that we discussed, that is a square minus b square concept, we can factorize this x minus 9, right? So I can write this x minus 9 as, okay, I'll write it as root x the whole square minus 3 square, right, plus root y minus 2 equal to 0. Now using a square minus b square, we can expand this as root x plus 3 times root x minus 3. That is equal to square root of y minus 2 equal to 0. Now from here I want to find out what is root y minus 2. I want to find out this expression. So we have to bring the rest of the terms to the right side. So I get root y minus 2 equal to minus of root x plus 3 times root x minus 3. Why did I get root y minus 2? Because in the earlier equation we had a term root y minus 2, right? So I have this equation written here for you. So here we are going to substitute this value of root y minus 2 in the place of this root y minus 2, so that we get which color should I use? Maybe I'll use purple. Okay, yes, root x minus 3 plus we have root y plus 2, and root y minus 2 is nothing but, I'll maybe how should I deal with the negative sign? Maybe I should have made this plus as minus before itself, right? So we have that negative symbol, so I will just make it minus in the beginning itself. Okay, so we have root y plus 2 and just write these two terms, that is root x plus 3 times root x minus 3 equal to 0. Now what we can do, you can see that we have root x minus 3 and root x minus 3 as a common factor, right? So we'll take it outside. So if you take it outside, we have root x minus 3 outside, and in the bracket here we have just 1, right? It's like 1 into this. So we have 1 minus these two terms, that is root y plus 2 times root x plus 3, that is equal to 0. From here we have the zero product rule, right? So we can equate each of the factor to 0. So we can equate root x minus 3 to 0, and we can equate this one to 0, that is 1 minus root y plus 2 times root x plus 3 to 0. Okay, so from here, from the first one, we get root x equal to 3, and if you square on both sides, you get x as 3 square, which is 9, right? So x equal to 9, we got one possible solution. Okay, and to get the y, you can use any of the other equation. Okay, we had two equations, right? That is we had root x plus y is equal to 7 or x plus root y is equal to 11. Maybe to find out y, I will use this first equation, root x plus y is equal to 7. So let me bring it here. So we have the equation root x plus y equal to 7. So substitute x as 9. So we have root 9, right? Root 9 plus y is equal to 7. Root 9 is 3. 3 plus y is equal to 7. So we get y as 7 minus 3, which is 4. So we get the value of y also. What about the second condition? Can we get some x and y values from this? Okay, so let me rewrite. Let me take this second term to the right side, so that we have root y plus 2 times root x plus 3 equal to 1. Now product of two terms is equal to 1. Is it possible to have such condition? You can carefully observe here that this term is clearly bigger than 1, right? Because square root of something is positive, plus 2 is again bigger than 1, and this also is bigger than 1. So we have two numbers, two positive numbers bigger than 1, whose product is 1. Is it possible? No, right? It is not possible to have two numbers bigger than 1 whose product is 1. So this condition will not be worked. So we'll reject that condition. So finally we have two solutions for x, that is x equal to 9 and y that is equal to 4. You can plug these values back in the equation and you can check it out. But I would not do that. I would leave that to you because I have to discuss another method. So I'll be discussing the second method now, by which you can solve these equations. Let me bring the equations in front of you once again. Okay, so we have the two equations in front of us. So this time the method that I'm going to use is a well-known method, and it is called as substitution, right? We want to get rid of the radical symbol, so we will substitute for those terms. So I'm going to substitute root x as a and root y as b. So now if you square on both sides here, you get x is equal to a square, and here you get y is equal to b square. We are going to substitute all these terms back in these two equations. So what will happen here? Root x is nothing but a plus y is nothing but b square equal to 7. And here x is nothing but a square plus root y is b, that is equal to what? It is equal to 11. Right? Now we have a system of equations which are free of the radical symbols. So how can we solve this? So from the first equation, what is a? So you can see a is nothing but 7 minus b square. Now I'm going to take this a and substitute in the place of this a in the second equation. Okay, so let me rewrite the equation once again. So the equation is a square plus b equal to 11. So a is equal to 7 minus b square. So a square will be 7 minus b square, and this should be squared because it's a square plus b equal to 11. So we have an equation with only one variable. Let's see if we can solve this equation. Expand this using the a minus b whole square formula. A square is 49 plus b square is b square the whole square, which is b power 4, minus 2ab will be 2 times 7, which is 14 times b square, plus b, and we will bring this minus 11 to the left side so that it will become minus 11 equal to 0. Let's write this equation in the decreasing order of the degree. So b power 4 minus 14b square plus b, and 49 minus 11 will be 38 equal to 0. This is a quartic equation, means the equation having a degree of 4. isn't it? So there is a standard formula, but it's a very lengthy and difficult formula. Okay, we'll not apply that formula. We'll use another very interesting concept called as rational root theorem. Okay, it's a trial and error method. So what we are going to do, we are going to take this 38, the last the constant term. We have to find out the factors of 38, both positive and negative, and we have to plug them in this equation and check which value will give us 0 as the answer. So as you know, 38, it is divisible by plus and minus 1, it is divisible by plus and minus 2, and it is divisible by plus and minus 19, and also by plus and minus 38. So which value will work? You have to plug in all these equations in the place of b and check, but I have already done that, and I know that b equal to 2 is a possible solution. B equal to 2 is a solution. It will work. You can check it out, right? You can plug this b equal to 2 in this equation and you will get 0 as the answer. So we have one solution, b equal to 2. So if b is equal to 2, then we can find out a also, right? We can use this equation itself here. A square plus b is equal to 11. So a square plus b is 2. This is equal to 11. So from here, a square is equal to 11 minus 2, which is 9, which gives us the solution a as plus or minus 3. But can we take the negative value for a? Recall what we substituted for a. We substituted a as square root of x, right? And b as square root of y. So both a and b should be positive. Okay, so we will reject the negative value. We'll only take the positive value, a equal to 3. Now set this here equal to 3, root x is equal to 3. So from here we get x is equal to 3 square, that is 9. And what is b? The value of b is 2, so set this equal to 2. So if you square both sides, we get y is equal to 4. So we get the same solution that we obtained earlier as well. X is equal to 9 and y is equal to 4. But can we say that these are the only solutions? Because here when we solved this quartic equation, we got b is equal to 2 as one solution by trial and error. But does it mean that that's the only one solution? We can have other solutions as well, right? So let me assure you, b equal to 2 is the only real solution. All the other three solutions of b are complex. Let me show you that with a very famous website called as Wolfram Alpha. I have not solved this equation manually. I have just inputted the equation and I will show you the solutions. So as you can see, I have solved this equation using Wolfram Alpha website. And yes, as you can see, b is equal to 2 is the only real solution. In every other solution, you have a complex number, isn't it? I is there. So all are complex solutions. We are interested in only real solutions. So we can finally conclude that x equal to 9 and y equal to 4 are the only solutions for those two system of equations. So I hope all of you enjoyed the solution. And for more such interesting videos, kindly subscribe to my channel. I will see you all in the next video.